So very first step is we should convert this time domain to frequency domain. That means we'll take its Z transform and we'll write this in terms of Z transform. So you can see y of n's Z transform is y of z. This is 3 by 4. Now this is y of n minus 1. So by using time shifting property, we can write this term. I'm writing it here. Y of n minus k is Z transform is always Z raised to minus k into y of z. Now here k is nothing but 1. So we'll get Z inverse into y of z minus 1 by 8. This is shifted by 2 unit. So we'll get Z raised to minus 2 into yz plus x of n Z transform is xz plus this term 1 upon 3. Now this is shifted by 1 unit, so it is Z inverse into x of z. Now in order to obtain h of z, we'll collect all y of z terms to one side and x of z terms to the another side. So by that we can write y of z, this term shifted, minus 3 by 4 Z inverse yz. This minus becomes plus 1 by 8 into y of z is equal to this term as xz plus 1 by 3 Z inverse into x of z. Now we'll collect all y of z terms. That means I'm taking common from that. So we'll get 1 minus 3 by 4 plus 1 upon 8 z raised to minus 2 is equal to, if I take x of z as common, we'll get this term as 1 plus 1 by 3 z inverse. Now in the next step, we'll divide y of z by x of z. So y of z upon x of z, it becomes 1 plus 1 by 3 z inverse divided by 1 minus 3 by 4 plus 1 by 8 z raised to minus 2. Now you know that y of z by x of z is nothing but h of z, that is transfer function of the system. H of z is ratio of y by x. Now we can realize this in cascade form by using direct form to realization. Now in order to obtain direct form to realization, and that should be connected in cascade with each other. So if you see, in the denominator we are getting some terms as 1 minus z inverse z raised to minus 2. So we can factorize the denominator term so that we'll get two different transfer functions. So for that we'll take factors of 1 by 8. Factors of 1 by 8 such that their addition or subtraction should be minus 3 by 4. So by that way, if I consider the first factor as 1 by 2 and other factor as 1 by 4. If you see, their multiplication 1 by 2 with 1 by 4 is 1 by 8 and their addition should be minus 3 by 4. So we'll take this as minus and minus. So if you add these two terms by cross multiplication only, we'll get this as minus 4 minus 2 by some 8, and by that we'll get minus 3 by 4. So the factors are minus 1 by 2 and minus 1 by 4. So we can write the same term as 1 plus 1 by 3 z inverse divided by, first factor I am writing 1 minus 1 by 2 z inverse, or we can take 1 minus 1 by 4 z inverse. Now we'll split this entire equation in two different transfer functions, let h1z and h2z, so that I'm writing it here. H of z is equal to h1z into h2z is equal to, we'll just multiply this term. So I'm writing 1 plus 1 by 3 z inverse divided by 1 minus 1 by 2 z inverse into 1 upon 1 minus 1 by 4 z raised to minus 1. Now this is our h1z and this is h2z. We'll realize this using direct form to realization. So as far as h1z is considered, we are having this is 1 plus 1 by 3, 1 minus 1 by 2, and this is h2z as 1 minus 1 by 4 z inverse. Now coming to this particular point, you can see numerator denominator both has only one delay element, so we'll adjust them. So here it is, this is x1n as an input. You can see only one delay element is required, so we'll take this is Z inverse. Now to the denominator we are having minus 1 by 2. So as per our rule, it becomes plus 1 by 2, one adder. So it is placed here. This is for all pole system. Now coming to the point of all 0, again we need 1 by 3 here. So this is multiplied with 1 by 3 and one adder. So we'll add this plus here. Let this is our first transfer function realization. Now coming to the part of H to Z, it is an all pole system. We are having all denominator coefficient. One delay element is required. So I'm extending this line, and one delay element will be added here, Z inverse. It is multiplied with minus 1 by 4. So it becomes plus 1 by 4, one adder that will keep it here, and this is being added, and this becomes our y2 and this is our y1. Now for H to Z, we don't have any numerator coefficients in terms of Z inverse, so you can keep like this or you can multiply with 1. So better way, we'll take the same line. This is 1 and you can take here plus, or it remains as it is. It will be one and the same. So this becomes direct form 2 realization that we have used in order to obtain cascade form realization. I hope you got this concept. The only difference is what in cascade form realization, whatever the system transfer function is given, try to factorize it so that we'll get multiple systems and then we can realize them. Thank you.